Thank you very much for the introduction, and thank you for the opportunity to be here with you this morning. So climate change in 10 minutes. This is a grand challenge here. So I like to call Nebraska the climate crossroads. We sort of lie at this intersection where east meets west and north meets south. Our climate is a function of our mid-latitude location, our position on the North American continent, our proximity to water, or lack thereof. We have a very arid climate in the east and a humid climate in the west. We live in a place where weather extremes are the norm and not the exception. We go from years like the flood of 2011 to the heat and drought of 2012, back-to-back years. This is not uncommon for us. This is very typical for a continental climate type. We also have something called a land-grant university here in Nebraska. We engage in teaching and research and extension, and my appointment, in fact, involves all three of those. We educate local and national and international students. We engage with the community. We bring research into operations. We make research useful and usable to impart meaningful impact. One of the most challenging issues of our time is our changing climate. The issue of global climate change can be difficult to wrap our head around. What does that mean for us here in Nebraska? In our state, the historical variability can often be much larger than the trend that we see. Think of climate change as being this escalator ride that we're all riding on, and it's increasing at an accelerating rate. And the variability that we have in climate, we're jumping up a few steps and down a few steps while still on this escalator ride. What you're seeing here is illustrating global average temperatures on an annual basis, that's land and water included, as well as Nebraska. And obviously you're seeing the trends, how they're actually the same for the globe and for Nebraska, and you're seeing the extreme variability that we have in the state. And what's different, obviously, is the scale, the global versus the local scale at Nebraska. Most of the warming that we have experienced in Nebraska has taken place during the colder time of year, there we go, and at night. And this is very typical for, this is a very similar trend for the US as a whole and for the globe, where most of the warming we've experienced at night and during the colder time of year. What you're seeing here are seasonal changes in temperature and precipitation over the period of record 1895 to 2016. So winter, that's when the changes in temperature have been the strongest. But keep in mind, however, when you look at these changes in temperature and precipitation, that it doesn't necessarily have to be a statistically significant trend to have some sort of physical or ecological impact. Even small changes and shifts can have an impact in what we experience and what we see. We know that springs have gotten wetter, so on the bottom of the graph you're looking at precipitation changes by season. We see the strongest trend historically during the springtime, where we've gotten wetter and we've had more days with precipitation. And if you're a producer, then this might be a trend that you've experienced, where it might be more difficult to get into the field when you need to. The best information that we have looking at the current model projections points to warmth in our future. All seasons are going to be warmer than what they are now. This is something that we need to plan for. And what I've done here is illustrate some seasonal changes in temperature as well as precipitation, and illustrated some possible impacts that might result because of these particular changes. Warmer during the nighttime, what will that do to the heat stress? If we don't cool down to a level that humans and animals can cool off, what will that mean in terms of human and animal health? Warmer during the winter, what will that mean in terms of pest survival? If we don't get as cold to kill off certain bugs and certain pests, what will that mean in terms of invasive species and so forth? Warmer during the summer, more extreme heat. What will that do to crop stress? a longer growing season, a longer time period that we don't go below freezing. What will that do in terms of irrigation demand, both for the agricultural community or for just watering our lawns? In terms of precipitation, wetter during the spring and winter, so wetter during the colder time of year, possible delays in planting, drier during the summer. That's what the precipitation projections point to. There's a difference, seasonal difference, where wetter during the colder time of year and drier during the summer. So what will that mean in terms of water competition during the time of year that there's a lot of uses for water? Decrease in mountain snowpack. Obviously, this is not, we don't have mountains in Nebraska, but what we do rely on, in fact, is snowmelt runoff from the Rocky Mountains. And all indications are pointing toward less water equivalents in that snowpack and an earlier snowmelt. So what does that mean for the water that's flowing down the Platte River that we depend on? If we look at extreme events, and this is pretty consistent throughout climate models, climate model output and projections, is that we can expect more extremes in heat events, more days with high temperatures, say over 95 or over 100 degrees. That will have impacts to human and animal health. We can expect more flood events, more drought events. What will that do to runoff, for example, or plant stress? As I've heard a colleague say in regard to drought impacts, and I'm stealing this from her because I think it fits nicely with climate impacts. Climate impacts are like fractals, so the closer you look, the more that you see. In my 15 years as an applied climatologist, I've talked to a lot of different people on this topic of climate variability and climate change. And how someone or something is affected by climate is unique, and it's local, and it's personal. There's a wealth of data available out there. It could be hydrological data, meteorological data, biological data, produced both within and outside of the university system. In my opinion, where a gap lies, however, is turning that data into usable and actionable information for those who make decisions. Natural resource managers, the energy industry, agricultural producers, municipal planners, the general public. What are some key characteristics of actionable science? Fact-based and trusted. In fact, there was a survey done with corn producers in the central US, and what they found was who do people trust for climate information? University researchers and university extension. So there's a ripe opportunity for imparting this information and putting it into actionable science. What's another key characteristic of actionable science? Relevance for decisions. And the way we achieve this is through engagement. If we want Nebraska to respond to our changing climate, then we need a level of engagement that results in an understanding of management decisions and brings that science to the table. If we can't map our climate information to specific decisions, then we've missed our mark. So I'm fortunate to work in what I call a boundary organization at the university, and there are examples of this other than the state climate office. There's a regional climate center, there's a national drought mitigation center, there's a cooperative fish and wildlife unit, there's university extension. So this means that I live at the intersection of science and stakeholder. I'm constantly learning from individuals and groups that I engage with. And I often get asked the question, what does climate change mean for me? Which is not a very easy one to answer. And I give them something that's admittedly vague. I say it depends. It depends on what decisions you make and at what time scale and what is important to you. What are you planning for? How would you like the information presented to you? So as I see it, it's through these conversations and engagement of stakeholders. I forgot about my other slide, that will respond to our changing climate in a meaningful and actionable way. And what you're seeing here is an illustration of that engagement, bringing science to the table, interacting with municipal planners to see what decisions are you making? How can we best bring climate projections to that table and help you with your decisions? Or engaging with natural resource managers. How are you thinking about how climate change will impact fisheries and wildlife? What sort of projections would you like, and at what time scale? And how should the information be presented to you? And with that, I will close. Thank you very much.